Welcome to the session of Indexes in Oracle. Indexes in Oracle video tutorial will be covered in 8 parts, and this is the part 1. In this part I will discuss about B-tree index fundamentals. Indexes in Oracle video tutorial will be covered in 8 parts. In part 1 I will discuss introduction to indexes, B-tree indexes, index scan methods. Part 2, B-tree index types. I will discuss about different type of B-tree indexes like descending index, reverse key index, key compressed index, IoT, cluster index, etc. IoT also I will discuss in detail on the part 4. Part 3, using B-tree indexes. In this part I will discuss why and when B-tree index should be used and different factors related to B-tree access. Part 4, index organized table. Part 5, bitmap indexes. Part 6, partitioned indexes. Part 7, other type of indexes based on characteristics and use. Part 8, managing indexes. Indexes are schema objects associated with tables and clusters that may allow your SQL query to execute more quickly if used properly. Typically, indexes can help to optimize your query when properly used. Also, indexes can impact the performance of DML operations such as insert, update, delete. Types of index. Indexes can be categorized into following types based on the structure: B-tree indexes, bitmap and bitmap join indexes, partition indexes. B-tree indexes are of different types like ascending or descending index, reverse key index, B-tree cluster index, key compressed index, index organized table, or IoT. Indexes also can be categorized into following types based on their use or characteristics. This is basically from the developer point of view. The indexes will be like composite index, unique and non-unique index, function based index, application domain index, invisible index, virtual column index, virtual index. B-tree or balanced tree indexes are most commonly used type of indexes in Oracle. They are similar in implementation to a binary search tree. Their goal is to minimize the amount of time Oracle spends searching for data. B-trees provides excellent retrieval performance for a wide range of queries, including exact match and range searches. Typically, B-tree indexes are very much useful when you are using B-tree index to retrieve very small number of rows from your table. And there are other situations also when B-tree indexes will be very much useful. I will discuss later on. Okay, so let's look how the B-tree index structure is. Okay, if you think conceptually, B-tree index structure looks like this particular diagram. B-tree index has two type of blocks: branch blocks for searching and leaf blocks that stores the index key and row ID values. Upper level of branch blocks of a B-tree index contains the indexing data that points to the lower level of index block. Like here, this points to a lower level of branch blocks. This the most upper level of block is a root block. This is the lower level branch blocks. Okay, and the lowest level blocks in the tree are called the leaf nodes or the leaf blocks. Leaf block contains the combination of index key and row ID, and this row ID points to the table it is indexing. Okay, these branch blocks are used to navigate through the structure. In B-tree index, all leaf blocks should be in the same level in the tree, meaning that any traversal from the root block of the index to the leaf block will visit the same number of blocks. This level is also known as the height of the index. The height of index is the typically number of blocks required to go from root to leaf, and B level or the branch level is the number of branches. Okay, this is typically height minus 1. It does not count the leaf blocks. In B-tree indexes, this is typically the height. This represents the number of blocks you have to visit to go from root to leaf, and B level number of blocks you have to visit from the root to last level of branch. Okay, so this diagram, there are two level of branches. This is root 1 and this is branch, and there is two level. B level is here 2 and height is 2 plus 1 3, including the leaf level. Okay, so what it says, like if suppose you have created an index on employees table. Suppose employees table have more than 20 lakh data, and in employee ID column you have created the index. Now you do a select of select star for employees where employee ID equal to 100. It will visit suppose 3 number of blocks. It will do suppose 3 number of IOs, and if you do another select employee ID from employees where employee ID equal to 18 lakh. It will also visit same number of blocks. Okay, so we'll check that. And another thing related to B-tree index are B-tree indexes does not store any null values. Only in case of composite indexes, like you can store null value in as long as one column will have the non-null values. Like suppose you have created a composite index on two columns A and B. B may have the null values as long as A contains no null. Okay, so this, let's check the B level from all indexes. I have created several indexes on this particular table using these scripts here, and let's see the B level from here. Okay, here this for two indexes, EMPL demo ID indexes. This is on the employees ID. B level is 2, so ideally height will be 3. So to view the height, you have to analyze the index and validate the structure. I'll validate it, validate the structure of this particular index, and you can visit the, you can see the height from here. Height is 3. Okay, so another thing, let's turn on our auto trace. Okay, I'll execute a query, select employee ID from MPL demo where employee ID equal to 200. It will do, it have done 3 number of logical IO, 3 consistent reads for employee ID 200. Now if I visit for some other record, employee ID 3,15,000, a bigger value, ideally it should do, in any cases it should do 3 number of IOs, 3 consistent read. It is just doing index unique scan. And now go to extreme value for 19 lakh. It will also do 3 number of logical IO, 3 consistent gates. Okay, and let's do another thing. I'll now check for select star from. As of now it was not visiting the table, it was giving us the data from the index itself. There is no table access by index row ID. So let's do a select star from MPL demo where employee ID equal to 200. So here you can see 1 additional consistent gates here. Okay, that is for table access by index row ID. Okay, total 4 logical IOs. Okay, so let's go to our next slide, index scan methods. Index scan is the method to retrieve a row by traversing through the index using the index column values or the index keys specified by the statement. Basic concept of index scan is, first the index scan locates the root block of the index, then it descends through the branch level of the index, then it goes to the particular leaf block that have the first possible entry, the start key that you have mentioned in your query predicate. Then it works along with the chain of leaf blocks until it reaches the entry that is the last possible entry or the stop key that matches your predicates. For each index entry, if it requires, it visits a table block. For example, suppose you execute this query, select star from employees where employee ID equal to where employee ID between 100 to 200. Okay, if you execute this query, the search will begin from here, then it will go to this particular branch, then from here it will look that this is the point where the search will start for the leaf blocks. This is the start key, and the search will continue. First it will search here, then it will go here. First it will search the first leaf block, then it will go to this one, then it will go to the last one, and the search will stop here. Thus this is 200, this particular here it is the stop key, and it will retrieve the values from the table using the row ID. Okay, so this is how index scan works basically. So these are the different type of index scan methods. Full index scan. In a full index scan, the database reads the entire index in sorted order of index key A full index scan is performed in cases like you are selecting the whole index column and using the order by with that column. In all of the column in the order by clause must be in the index. The order of the columns in the order by clause must match the order of the leading index column. Okay, so let's see example. This actually you cannot just guarantee this particular scan method will occur when you execute queries. There are several factors that can influence. Okay, so I'll execute this query. Selects employee ID from hr.empl demo order by employee ID. So let's see what happens. Okay, just stop. I'll turn on my auto trace. I forgot earlier. Set auto trace trace only. Now I'll execute this. Ideally it should do index full scan. Yeah, it is doing index full scan. Okay, so it is doing the in case of index scan, it is reading the whole index in a particular order of index key. Okay, so let's go to our next slide. Index fast full scan. Index fast full scan is a full index scan in which the database accesses the data in the index itself without accessing the table, and the database reads the index blocks in no particular block order. And this is a optimal access method when all information required to answer the query is contained in the index columns. In fast full scan, multi-block read happens. Basically there is no ordering. It is fetching the data from the index randomly. Okay, index fast full scan happens generally when the in cases like the index must contain the all columns needed for the query. A row containing all null must not appear in the query result set. A group by clause is present in the query, and the columns in the group by are present in the index. So let's check. I'll first generally when you do a count operation of the table, it generally happens like it does generally fast full scan. Here you can see index fast full scan. I was doing a count of employee ID. Then I'll execute another query. In case of fast full scan, it scans the index in like a random order, like so. I have created another index, sorry, on department ID, email, salary. Now I'll execute this query. Select department ID, sum of salary from this table or the group by department ID. So let's see what happens. You can see it is not visiting the table, it is doing the index fast full scan. It is getting the data from index itself, then it is doing the hash group by to give you the aggregated result. Okay, let's go to next slide. Index range scan. An index range scan is ordered scan of index. It happens when index is scanned for a range of values. You are using a range predicate. One or more leading column of an index are specified in conditions like this: equal to or less than or greater than, between, like, and combination of any of the preceding condition for leading columns in the index. Index range scan typically happens when you use any range predicates. Okay, also equality when you use select star from employees where employee equal to something. In some cases you might see it is doing range scan. It depends, but in general range scan happens like you are doing a less than, greater than, between, this kind of range predicates. Here you can see it is doing a range scan. Range scan is similar example that earlier I was giving, like the journey will start from here, then it will go to here, then it will find that the start value will come from here, start key. It will range the scan the values from here, then it will go to the next, then it will go to the next, until the value that is mentioned in the range predicate, the maximum value, when it gets, it stops. Okay, so this is how the range scan works. In cases like between, or less than, greater than, you might find it is doing index range scan. Index unique scan. The database performs index unique scan when a predicate references all of the column in a unique index using an equality operator. It should be a unique index. Okay, an index unique scan stops the processing as soon as it finds the first record, because no second record is possible, because you are accessing using a unique index. It will not have any duplicate value. Okay, so let's check. For example, like select star from select star from hr.empl demo where employee id equal to 1000. It is doing index unique scan on this particular index, and it is getting the row id, and it is accessing the table using this particular index row id. Now the last one, index skip scan. In index skip scan, Oracle skips the leading edge predicate in a composite index. So basically how it works, Oracle mainly uses the skip scan in cases like you have created a composite index on two columns, and the leading column may have very less number of distinct values and the other column may have more distinct values, and the leading column is not used in your query predicate. Okay, to show you skip scan, I have I have created an index, composite index. On EMPL demo table there are two column, manager name and login. Manager name will have very much repetitive value and login will have very less login will have very less number of repetitive value, or it will have the all distinct values. Okay, and manager name will have lots of repetitive values. So let's check. We have created this index, and now I will execute this query, select star from this table where login equal to something. So here you can see it is doing index skip scan. It is not even I am in this particular two columns. On this login there are unique values, and in the other value in the other column manager there will be lots of repetitive values. So I am in my query I am using only the login column where login equal to this, then it is doing the index skip scan. Okay, so these are some example of index scan methods.